Hey there, TouchDesigner developers, Jack DiLaura here with the Interactive and Immersive HQ. In this video, we're going to work on creating a chromatic aberration inspired effect in GLSL. Chromatic aberration is a phenomenon from the world of optics in which a lens doesn't focus all of the colors at the same point. So you'll often see in photographs or videos that the color layers are kind of shifted a little bit and will give this sort of fringing, haloing effect around objects where you can start to see those separate layers. So we're going to approach this via creating an effect in GLSL where we can control the position of the independent color layers of our top texture, as well as the scale of those layers. So this will enable you to both recreate the chromatic aberration effect and experiment and generate some interesting color shifting effects of your own. All right, so let's get started by adding a movie file in top to the network. You can apply this effect to any top texture that you like. I'm just going to use the movie file in because we can grab the jelly beans image that we saw in the intro, which provides a really good example, easily recognizable which color channels are being shifted. So what I've done here is just click on the plus next to the file parameter. I'm going to grab jellybeans.1.jpg from the sample folder, hit open, and there we go. We've got that image loaded in. Now we're going to go straight to the GLSL top. If you've never dealt with this before, the GLSL top also comes with some additional DATs, some of which are the code that GLSL top runs, and then one other important one is the info DAT, which is where we'll look for things like error messages and to find out whether or not our shader has compiled successfully. So before we dive into the code, I just want to cover some parameters that we're going to adjust within the top first. So you'll notice here that we have a number of different pages within the parameter window. We're not going to deal with that many of them today, but the one that we are going to look at is the one called vectors, the second page. Here we can define something called uniforms, which are a common tool in the world of GLSL. Uniforms allow us to take information from outside the GLSL shader and route it into the shader. So in the case of working with these shaders within TouchDesigner, that means we can take things like chop channels or even just static numeric values and send those into our shader and then, of course, control them in real time from outside the shader with any number of interactive tools. So when we define a uniform, we will give it a name and a value. You can see that our value is a kind of standard 4-unit vector, meaning that we have 4 components that we can adjust. We will later on be defining specific data types within our code to specify basically how many of these numbers we're pulling in for that particular value. So you could just pull in a single value for something like a float, or if you want like an XY position, you can pull in a 2-unit vector up to a 4-unit vector for something like RGB and alpha. So anyways, we're going to set up a number of these right now because we're going to use them to control things like the positioning of our individual color layers as well as the scaling of those layers. So a common kind of approach to naming your uniforms is to put a lowercase u at the beginning of the name, which will then make it very easy within the code to understand which values are being pulled in from those uniforms and which are just sort of exclusive to the code. So the first one here I'm going to call U capital input and then capital R-E-S, U input res. This is going to be used for calculating some position values within our code later on, and basically we'll pass in the resolution of whatever is connected to the first input. So now that we've defined a name for our uniform, let's go ahead and set the values for this uniform. So the way that we're going to approach that is via a Python expression. I'm going to type in me.inputs and then a pair of brackets and then 0 within the brackets, which will grab the operator that's connected to the first input of our GLSL top. I want the width of that texture. So I'm going to then type in .width, and then if I hit enter, we should see a value of 1280. If I then middle mouse click on the movie file in top, you can see that we have a width here of 1280, so that is correct. For the second value, I'm going to copy and paste this expression and then change the last part here from width to height. And that should read 720, which again, if we middle mouse click on the movie file in, we have a value of 720. So we're all set there. So next we're going to set up a uniform vec2. So that's a 2-component vector called uRedPOS. So that's going to be the position of our red channel. We're not going to set up expressions for the values here, but just to remind myself that this is going to have an X and Y position value, I'm just going to turn or change these last two values here to 0. We'll follow that up with uRedScale. So that's the scaling of the red channel. That's just going to be a single value, a float. So I'm just going to change all of the other components of that to 0 and leave the first value 1. We're going to continue down the line here with the green channel and then the blue channel. So uGreenPOS, set the last two to 0. uGreenScale, last 3 here to 0. And then finally, uBluePOS, last 2 to 0. uBlueScale, last 3 to 0. Cool, so those are all set up and ready to be used within our code. So let's go ahead and open the code here in an external code editor. So you'll notice that we already have an example pixel shader written here, and that's great because we can actually use some of this code as an example for how we're going to write our particular shader. Up top under the title, we have commented out currently uniform float example uniform. This is how we can actually pull in those uniform values from our GLSL top. So what I'm going to do here is reduce the width of this window just a little bit, head back to touch momentarily and just highlight the GLSL top so we can remember what all of those names are. And I'll flip back to the code editor and we can start writing our code. So what I'm going to do is uncomment this line first of all. We're not going to define our floats first. I'm actually going to define our vector2. So this is a 2-component vector variables or uniforms rather first. So if we remember the 2 components, 2-component vectors were the input resolution and the 3 position values for the different color layers. So I can actually type those in all on one line. So I'm going to start off by uInputRes. So that's defining the name there. And then if I put a comma and type in uRedPOS, that will define a second uniform vec2 with that particular name. Then we want one called uGreenPOS and uBluePOS. It's really important to note that these names need to be spelled exactly the same as they are found here. Otherwise, you will not be correctly pulling in the value from touch. We're going to follow that up with a second set of uniforms, and these will be the scale values, which are floats. So we want a uniform with the float data type, and then we want to do our red scale, green scale, and blue scale. Also note that this is not Python, so we do need semicolons at the end of the line in order to compile the code correctly. So I'm just going to go ahead and save that so that I can move on and not lose any of my progress here. Here we are defining a kind of standard component, which is our output vec4 called frag color. That's just going to take what we're doing in this code and then send it back to TouchDesigner essentially. And below that, we have the main function, which is where all of the good stuff in our GLSL code is going to be happening. So right now we are simply outputting a RGBA value of 1, which means a color of white for every single pixel in our texture. That's another important point to note here, is that our main loop is going to iterate over all of the pixels in our texture. And again, we're applying white to each one of those pixels. So right now we just get a texture output of white. Now, if we wanted to do something like sample the jelly bean texture that's connected to the input, instead of just changing all of our pixels to white, we could comment out this color line here and remove the forward slashes on the previous line. So we're sending this std2d inputs expression into the texture function, and this is actually a specific TouchDesigner piece of code here that is grabbing the first input of our GLSL top and then enabling us to use that within the code. So if we wanted to use, say, the second input, we would just change this index value here, very similar to how we work within TouchDesigner, and we could grab the texture from the second input. This last component here looks maybe a little bit funky if you're not familiar with working in GLSL. So when working within GLSL, we don't think in terms of pixel position values in the same way. GLSL uses a normalized 0 to 1 range so that these values will essentially be the same and easier to work with than they would if we constantly had different values for positioning based on the resolution. I'm sure this also has to do with some kind of efficiency of working on the GPU and stuff like that. But essentially, this value here is allowing us to pull two components of an array or a larger vector, which give us the XY position in that normalized value of the current pixel that we're working on. So essentially what that means is that as we're going through each pixel in our jelly bean texture, it's making sure that the pixel that we are currently working on, whatever the color value is of that pixel, is then copied over to the exact same position in our kind of copied version of the texture that we're generating here in this code. So this is a bit complex to think about if this is your first interaction with GLSL. We don't have to get too much more complex than that. Just note that by applying math to this value, we can then shift things like the position of the texture in our output as well as the scale of that texture. And that's exactly what we're going to do as we code the rest of this shader. So before we dive into sampling, I want to set up a number of variables for us to use to allow the position values that we set up here to be defined in pixels. So the way that we approach that is by setting up a new series of vector2s, which I'm going to call, in this case, red POS, so whatever the color channel name is, and then POS. Note that because this is not a uniform that we're defining here, we will not be adding the U at the beginning of that name. I'm going to set that equal to the U red position uniform and divide that by the U input resolution that we set up earlier. So that's all set for that line of code. I'm just going to duplicate that 3 times, and then for the second one here, I'm going to set this second vec2 to the name green POS, and then change the corresponding uniform to the same channel. And then I'll do the same thing for the final vec2 here and set that to the U blue POS uniform. So cool, we've got those set up. And then we're actually going to reuse this line of code that we commented out here, where we set our vec4 color equal to essentially a color of white. I'm going to move that up and uncomment it. So we're setting up our color vec4 to white at the beginning here, just to ensure that we don't have any junk information in that vec4 at the beginning, which is especially important for the alpha channel because we're not going to be setting that with any of our sampling that we're doing in this code. So we've now set up that that vec4 that we're going to use for supplying our color to the output. And so we can actually reuse this line of code at the bottom here, but we're just going to have to modify it a bit. So I'm just going to move that up. Now, we don't want to define an additional vec4 called color in this case. So I'm going to delete this vec4 part from the beginning, and instead we're just going to modify the vec4 color that we've already set up. Now, because we want to work with the individual color channels of this vec4 rather than setting the entire thing to the RGB channels of our texture, I'm going to type in .r after the vec4 name to specifically modify the red channel of that component. This is a great way to easily be able to work independently on the color channels of our texture within GLSL. Now, our texture function in its current format is going to output a vec4. So we're going to get RGBA channels out of this texture function, and trying to assign those channels to one component of a 4-unit vector is going to result in an error. So much in the same way that we've just done this here, where we've specified the particular channel that we want to work with, we can do the same thing with our texture function. We can add a .r at the end and only grab the red channel from that particular function. Now, right now, what this will do is simply take the red channel of our jelly beans texture and apply it to our output. We won't have any ability to work with our uniforms, position, scale, or do anything like that, which is, not super interesting. And so we're going to, before moving on, add a little bit of math in here and work with these uniforms that we have defined in order to be able to shift the position and scale that texture. I'm going to go ahead and save here, and then we'll work on that. So if we want to move the position of the texture that we're generating, we can add or subtract from this vuv.st 2-unit vector that we are, again, getting our texture coordinate from. So we're going to use our positioning vec2s that we set up above to modify this value. And in our case, to make this positioning intuitive in that moving a value in the positive direction, if we're talking about our X position, will move us to the right, and negative will move us to the left, so on and so forth, we actually are going to subtract the position value from our vuv.st component. So I'm going to subtract red POS, not post, but POS from vuv.st. If we hit save and head back to Touch for a moment, you can see now that we actually have part of our image brought into our output. And the reason that it's blue is because we have values of 1 in all of our other color channels. So we are, not seeing our full image. If I then move the red position value, we should see that our texture is able to be moved to the left and the right. So that is functioning like it should. Now, if we want to modify the scale of our texture, we will, instead of adding or subtracting from our VUV component here, we're going to be multiplying or dividing by this value. So in our case, we're actually going to be dividing our scale value, or rather, we're going to be dividing the vuv.st vec2 by our scale uniforms that we set up earlier. And again, this is to work in a more intuitive way where our scale values, as they get smaller, will cause our texture to reduce in size, and increasing those values will cause it to increase in size. So I'm going to divide that by our U red scale for this channel. If we then save that, head back to Touch, we should be able to modify this uniform 2 here and increase, and then also reduce the scale of that layer of the texture. So that is functioning exactly like it should. We can now simply copy and paste those lines of code and modify them for the additional channels, and we will be all set with our code portion of this tutorial. So I'm going to just duplicate that line 3 times and make the modifications to the next 2 lines. So for the second line here, I'm going to set the color portion of that vector to the green channel. So color.g, then everything will stay the same up until our red components, where I'm going to change this to read U green scale instead, and then green POS. And then of course we want the green channel of our texture as well. So I'm going to type in .g there. Then for our final line, I'm going to set, we want to modify the blue channel of our texture. We're then going to set that equal to texture, leave everything the same. Again, we'll come down to the scale parameter, change that to blue, change our position parameter to blue, and then we also want the blue channel of the texture. So that is everything that we're going to be writing for this particular shader. If we then hit Control S to save and head back to Touch, we should now see our jelly bean image in its full glory with all the color channels aligned, looking exactly like it is supposed to. So now if we were to modify any of these different parameters here, you can see that we can shift those layers independently of one another in the X and Y direction, and that will give us the chromatic aberration effect that we are looking for. So again, that's all the coding that we're going to be doing, but I did want to point out one additional thing before we close out this video, and that has to do with the edges of the texture, which we can see here that look a little bit funky. So I'm even going to move these positioning of the layers to something a little bit more dramatic so we can see what's going on here. So essentially what's happening is that we've shifted the position of the texture so much that the sample function that is, again, pulling that texture in and outputting it has no more texture to grab from in these bands that we see on the screen. The GLSL top gives us the ability to choose how we want to deal with these situations where we run out of texture on the GLSL page. So you can see here that we have something called the input extend mode, which is currently set to 0. This is what is choosing how we will deal with that situation where we need to extend our texture. And if it's set to 0, we will get a value of 0, which will give us these bands. So if we were to do something else, like use the repeat function, our texture will be essentially looped at this point here, and we'll get the portion of the texture that is currently cut off on the right. If we change it to mirror, it'll mirror the texture along that line. The mode that you choose to work with will depend on the texture. In certain situations, you can get somewhat more seamless edges like we have here. You may not be able to ever find one that works perfectly, but you do have these options to work with so that you're not left with these very obvious bands. The other thing that I wanted to point out, and I've set my UV extend mode here to repeat, is that besides chromatic aberration, we can have a lot of fun experimenting with this effect for other creative results. So as you can see right now, I've pretty dramatically shifted the position of those color layers, which is, something way beyond chromatic aberration and kind of an effect in its own right. We can, of course, scale up and down the different color layers. And the other thing that I wanted to show you is that besides just scaling the image or the layers of the image up in size, you can actually reduce the scale of those images and work with the extend modes to actually generate something like tiling. So if I change my scale values here to something like 0.25 for each one of these channels, you can see already that I have a tiled version of that texture generated on screen. What's happening is that our texture size is now so small that we have a lot of space with which to use that extend function. And again, we can change the mode here to generate some different results. I can use mirroring. I can set it to 0 again, so that we just have 0 around the image. We can use hold, which will just hold the pixel values at the edge. It's not perhaps that interesting in the mirror mode for this particular image, But let's say if we try a different image, you can see how this might be interesting. So I'm going to set the position values closer to 0 so that our color channels are aligned. And then let's just try a different image very quickly. So I'm going to try this Trillium image. And you can see here how, in this case, the mirroring effect actually generates something pretty cool and unique. And then, of course, you can go in and play around with the shifting of the layers to your heart's content. So that's actually it for the tutorial today. I hope that you have enjoyed putting this together and that you've learned a little bit about how you can work with some of the simple tools available in GLSL to get under the hood and modify your textures in interesting ways. Looking forward to seeing you in the next video here on the Interactive and Immersive HQ. Thanks so much for watching.
Hey guys, thanks for watching. If you're serious about taking your TouchDesigner and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.